Okay, so let's look at this one. Anytime we see an x squared, we'll want to have to deal with that. Since I don't have another term outside of this square root with an x, I cannot use substitution. So instead, I'm going to complete the square. So negative 2 plus 9x minus x squared. To complete the square, I always look at this term in front of x, dividing it by 2. That gives me 9 over 2, and then I square that, which is 81 over 4. Since I don't want to actually change the problem, I will both add and subtract 81 over 4. This way, all I'm really doing is adding 0. I'm going to rearrange this slightly and pull out a negative sign and make it x squared minus 9x plus 81 over 4. And that way this term right here factors into x minus 9 over 2 squared. So I still have a plus 81 over 4 and a minus 2. So this gives me 73 over 4. So I can now rewrite this as 1 over the square root of 73 over 4 minus x minus 9 over 2 squared dx. And I'm going to do a small substitution. I'll let u be equal to x minus 9 over 2, so that du is equal to dx. So this is now the integral of 1 over the square root of 73 over 4 minus u squared du. And this is now of the form of the integral of sine inverse. And it's always sine inverse of x, or in this case u, over a. So this 73 over 4 is actually the square root of a, or is actually a squared, so we need the square root. The square root of 73 over 2. We'll substitute back in and get sine inverse of x minus 9 over 2 over the square root of 73 over 2 plus c, which can then be simplified to sine inverse of 2x minus 9 over the square root of 73 plus c. Let's look at this one. Currently, we may not see exactly what to do. And anytime you see an e to the negative x and you're not quite sure how to deal with it, I suggest multiplying by e to the x over e to the x, which is just 1, so I haven't really changed anything. That makes this the integral of e to the x over e to the 2x plus 1 dx. And I'm just going to let u be equal to e to the x, which makes du the derivative, which is just e to the x dx. So this is now the integral of this e to the x on the numerator combined with this dx, just becomes du. And the denominator becomes u squared plus 1. And this is tangent inverse of u over the square root of 1, which is just 1. So tangent inverse of u plus c. Substituting back in, I get tan inverse of e to the x plus c. For our last one, we'll look at this. Currently, I do not know how to deal with this. So I'm going to multiply by 1 like I did in the last example. Except for this time, I'm going to do something similar to rationalizing a denominator. And I'm going to multiply by the conjugate. 1 minus sine x over 1 minus sine x. This makes this the integral of 1 minus sine x over cosine squared x. since 1 plus sine x times 1 minus sine x is actually 1 minus the sine squared x, which is just cosine. And then I can split this to 1 over cosine squared x minus the integral of sine x over cosine squared x. Simplifying some trig functions, 1 over cosine is just secant. So this is secant squared x dx. And sine over cosine squared simplifies to secant x tangent x. The integral of secant squared is tangent, and the integral of secant tangent is secant.